Hello and welcome to the Earth Observed podcast, a podcast where I sit down with the founders, the technical leaders, and the minds shaping the future of Earth data, geospatial technology, and atmospheric AI across Europe, North America, and beyond. In each episode, we take a vertical dive into a topic chosen by our guest, giving you a front row seat to the ideas, the tools, and the challenges that enable innovation from space to subsurface and everything in between. Today, I have the absolute pleasure of being joined by Samuel Barrett, who has 8 years of experience working in Earth observation and machine learning. After spending much time on his applications, he is now diving into the world of foundation modeling and geo AI, and is now an AI research engineer at Legend AI. Samuel, thank you so much for joining us today. It is much appreciated. First and foremost, how are you?
I'm doing well, thank you. Thank you for having me.
Well, do you know what? Me and you have, I feel like, known each other virtually, I guess, for some time now. We've had plenty of great conversations, both, professionally and personally. And you're just an awesome guy. So I was really, really excited about having you on, especially as well with some of the developments, in recent times with you, as I've mentioned, joining Legend AI. No doubt some people now watching this are going to be aware of the business and some of the work that you guys do over there. But today, just to give some context, we're going to be talking about the future of AI in Earth observation. I guess before we dive into the discussion there and the multiple topics that we want to cover, why don't you give our audience just a very, very brief teaser into the future of AI in Earth observation and what we might cover?
Sure. So I think the big picture is what we've been doing till now has more or less been an iteration of what we've done in the past. And I don't want an iteration. I want a revolution. I want us to realize the big promise of Earth observation. And I think we are so far from what can be done. And so, yeah, I'm looking not for what is a small step from now, but what can potentially reshape how we approach Earth observation. And if there's one kind of tagline, which we'll dig into, it's most Earth observation problems are some combination of finding things at scale and then understanding them in depth. And the answer to that, we will come to. How does that work?
That is why I wanted to do this episode with you. I think, yeah, it's overdue. Let's kick things off. So, starting off with a very, very simple question. In a sentence, what problem are you solving that no one else truly gets yet?
Forced into just a sentence, the problem is we haven't had our revolution in Earth observation, and I want it.
Okay. Tell us about this revolution in Earth observation, because you've spoken about that twice now, and I want to understand the difference between the revolution and what is considered the iteration at the moment. What are we missing here?
Yeah, so let me frame this in what's been going on in kind of broader AI recently. Right now, you have frontier models, you have ChatGPT, your GPT models, Gemini, all of these, and these this technology it's completely reframed and reshaped the underlying fields of language modeling and computer vision, and beyond that, it is having a massive impact at a societal level and an economic level as well.
Yep.
And if you take that picture, that like what's happening in language and computer vision is nothing like what was 5 years ago. That where we are now is essentially unexpected from that previous perspective. But if you look at Earth observation, we have taken some really good first steps into foundation modeling, into using kind of cutting edge AI, but we are the way that it's the impact it's having is still pretty much an iteration on the past. It is useful, it is valuable. We can go into details, but it's not having anywhere near the scale of impact that is happening in broader AI right now. And for a long time, I've been trying to figure out why, and I have a thesis on why that is now.
Okay, and look, I'm gonna ask you simply: is it an adoption problem as well? Like, is maybe Earth observation behind in comparison to adjacent industries? Where is are we hanging on to technology that maybe is considered legacy still?
think um, I think that the technology and the adoption are kind of second order things. I think the first is a kind of perspective issue. I think we we built we've built a certain way of doing things in Earth observation that very often involves maps and generating you know, lots of pixels, um, and that a lot of the discussion about where we go from here is essentially in like, how do we do this that we've done before? How do we do this but a bit better, a bit cheaper, with a bit less data? Rather than what are we trying to solve more fundamentally? What are we really trying to do, and how do we think in terms of the new tools we have from other fields of AI, and reimagine how we solve problems in Earth observation? So ultimately, I think we have so far mostly built for past and for an iteration of the past, and we need to think, how do we reimagine how we approach problems and use, as I say, this fantastic technology that's coming out of the broader AI revolution.
And also, as well, from a non-technical standpoint, I've seen plenty of businesses across this space start to introduce agentic AI and kind of like large language models into their platforms and products. Introducing assistants and kind of co-pilots, quote unquote. Given this wave, I'm keen to understand what makes a good LLM and what doesn't, if that makes sense. If that's a silly question, do let me know. And also, like, are we testing, are we pushing the boundaries of generative AI, or are we just adding a feature because it is cool, it's current, it sounds great?
Okay, let me just say a couple of things. That what LLMs have done in language modeling is that they've taken language modeling from how do we make a better text classifier to how do we do anything we want to do with language, anything that you can frame in language. And in Earth observation, what we've been doing for a long time is, more or less, how do we do a land cover map? And what we are currently doing is still a bit really just how do we do a better land cover map? And not what changed language modeling. What changed language modeling is you have this framework that it's open ended, it's flexible. You can any input to any output. That is the generative part of generative AI, and that's what made it really different. You said what makes a good language model. I think the key components of a useful language modeling system are two things. One, having the model itself. You need low hallucinations. You need it to be good reasoning model. There's all these kind of parameters of frontier cutting edge models these days. But that's not the whole picture. One of the a whole class of very useful things you can do with language models are kind of knowledge discovery and synthesis. That's the context where you don't just want what you are going to ask the model right then and there. You need it to be able to reference things and be grounded in search results, more or less. And so what's really key is having a system that you don't just have the frontier intelligence, you have the ability for that intelligence to draw in other information, basically through search and what's called RAG, through retrieval assisted generation.
Yeah.
And it's those components that I think together, it's not just the frontier models, it's also this search and RAG components, which are really important. And that really transfer then to my perspective on the future of Earth observation. I want to be in a situation where we can deploy frontier intelligence on Earth observation problems, but just like in language processing, you don't like ask ChatGPT some question about the scientific literature and it goes and processes tens of thousands of papers. It uses search to find which are the relevant ones, puts them into its context window, answers the question. How do we more or less do that in Earth observation? How do we have models, frontier AI models, with everything that brings, but have the ability to put exactly what is necessary, like what kind of imagery under their nose to answer questions? And the answer to that is more or less search and retrieval. How do we do that? in much the same way as it works in natural language with embeddings.
Well, yeah, and that's exactly what I wanted to come on to. Is there seems to be a bit of a misunderstanding as well at this moment in time, which is absolutely fine because I sometimes find myself, well, sometimes all the time, find myself in a maze, in a labyrinth of answers and questions, and in this particular field, and that's fine. I wake up every day comfortable with the fact that I am not fully up to date with what is going on, because things are moving at such a lightning fast pace that I've given up in trying to keep up with all the developments of every nook and cranny. But for the audience today, what do people misunderstand about building Earth or climate related products in general?
So I guess this is what I've already been talking about, that the question isn't how do we do our past processes better, but how do we do things differently? And more or less, how do we move into this paradigm of combining a queryable Earth with true frontier intelligence?
Right. Yes. Okay. I understand. So in regards to your interest in this field, because you speak quite frequently on LinkedIn, which is fantastic. I think that's actually how I came across yourself. If I'm perfectly honest, I think it's great. I think some of the work that you put out, some of the education, some of the free information that you put out there. There's people who are putting paywalls in front of this sort of thing. Who are putting Patreons up, who are to try and get access to that information. But I feel like that goes against the grain of what Earth observation is trying to achieve in open, accessible data. I'm keen to understand a bit more about your interest, and at what moment did the switch flip from this is interesting to I actually have to spend my time on this? Was there a moment when maybe you thought this isn't just an interest anymore, it's actually a matter of, I'm not going to say urgency. Urgency is I think exaggerated, but this is a matter of this needs to be studied, this needs to be deployed, this just needs to have some work, investment, interest shown onto it.
There's sort of two key moments. I guess about a year to 18 months ago, working on the front line of agricultural monitoring at the time, was two things were happening. First, I was generally kind of watching the development of general AI systems, watching the kind of what was going on with Earth observation foundation models, and starting to realize that a bunch of the kind of practical challenges in Earth observation modeling, it felt like the more I understood about what was possible from language modeling, for example, the more it felt like we were not approaching we weren't approaching them in a way that I don't know, almost in the right way, in the optimal way. We would take a problem like we need to know the crop that's growing in a field, or rather the problem is almost always in taking this example, in agricultural monitoring. Very often, there is a field, and you want to know as much as you can about it. You want to know a whole load of different things about it, like what's the crop, what's the potential yield, what's the history of cropping, what types of management practices we used, when did they occur, all these kind of things. And the way that's all been done, like since forever, is you train a model to do crop type classification. You train another model to do yield estimation. You train another model to do seasonality or something. And you take the data you have and you answer each question individually. And it increasingly felt like what we should be able to do, and if this was language, what we could already do would be, here is like 5 years of Sentinel data, and give me however many crops are actually in that period, what the crops were, when they were planted, when they were harvested. You should be able to have that kind of multiple and open-ended in terms of, like, maybe some years there was double, maybe some years it was fallow. Like, you should have modeling that can interact with the true complexity on the ground, rather than being like flattening every question into a data in, one answer out. And so I was kind of realizing that there was another way to approach how we were doing certain modeling tasks. And these kind of things were converging together and making me realize more and more that I wanted to work in the field of foundation modeling, because I think this has been part of the answer to what I was explaining. So that was the first kind of taking foundation modeling seriously, like realizing that I wanted to move more in that direction. And then the second was, earlier this year, I had a period unexpected unemployment rather suddenly, but within minutes of me hearing the news, I was immediately thinking, now I have time to work on like kind of ideas about generative modeling. Now I have time for diving into embeddings, which seem really interesting, and I haven't had a chance for such yet.
Yeah.
And I dove deeply into those two threads, and a few months later, I ended up at Legend.
So, foundation modeling is something you've just mentioned there. It's something that I have picked up on over the past, I'd probably say year. I think the first time I came across this was when I came across Clay, which,
Mhm.
from my understanding, has an association there with Legend AI. And of course, you can
Yes.
talk more about that in just a moment. But of course, there are other models out there as well. From my understanding, and do correct me if I'm wrong here, we've got Prithvi, the one there that's in collaboration with IBM and NASA. I know that Earth
Mhm.
Genome have been doing some really interesting work in that field. Once again, do correct me if I'm wrong there.
Mhm.
But tell me a bit more about foundation modeling and also in conjunction with embeddings, because embeddings is a very simple word, but I know that it means so much more than that.
So, foundation models in general, not just Earth observation, they are models pre-trained on very large amounts of data. And they're designed. There's a few different kind of flavors of them, which we can come to, but they're more or less designed to be a foundation, to adapting to some downstream task, and to make that adaptation much easier than if you started from scratch. Um, there are a few different flavors, as I say, and one is where you pre-train this model and you sort of you need to directly adapt it, and then you kind of run your adapted version of it. And this is most of the models that we have right now, like Clay, Prithvi, TerraMind, and others. They're more or less, this is how they were designed. They're designed that they pre-train them, and mostly the way you use them is you bring your data, your labeled data. Maybe TerraMind's not a good example, but certainly Clay and Prithvi and many of the others. You bring your labels, and you then a few different technical ways, doesn't matter, but you basically turn the model, that pre-trained foundation model, into a model that does the specific thing you want, and then you use it in production. That you basically drop it in where you would have had your own from scratch model. And that's when I say about like it's more or less the way we used to do things, but maybe you need less training data, maybe generalize is better.
So look, at what moment did the switch flip from "this is interesting" to "I have to spend my time on this"? And was there a moment when you thought this isn't just quite simply an interest anymore? This is a matter of this needs investment. This needs my coverage.
Yeah. So yeah, two key moments. One, about 18 months ago to a year ago, when I was working on agricultural monitoring. And three things were happening at the time. First, Frontier AI was developing like mad, and I was following on and those developments, and a bit kind of also the technical stuff behind, generally being inspired by that. Two, I was learning about Earth observation foundation models, and thinking, yes, these are important, and wanting to learn more and work more directly on them. And three, also with some of the kind of practical work I was doing, more or less realizing that the way that we've always done things in Earth observation in general, and especially in this case of kind of data to a single answer, wasn't really adapted to the true complexity of the Earth's surface. And in that particular case, for example, like describing agricultural processes and agricultural management, that's a complex, multifaceted field, and that flattening that to data in, crop type out, or data in, yield out, didn't seem to kind of match that true complexity on the ground. And me feeling that there was a better way, and since then kind of like developing my ideas about what that way could be, and more or less like being inspired by what's possible in language modeling. So that was going on, and that's where I started to think to myself, I want to. I've been enjoying working on these kind of applications a lot, but I'm really interested in the underlying tech, and I really feel like I contribute there. And so that's when I started kind of trying to turn the ship's wheel towards working in foundation modeling in Earth observation.
Sure.
And then the second is So,
No, no, please. I was actually going to come on to some of those foundation models there, but please, no, do continue. I'm intrigued.
sorry, I was just saying, yeah, the second moment, and perhaps the bigger moment, was that I had a period of unexpected unemployment earlier in the year, and once the shock wore off, I realized I had an opportunity to dive into the ideas that had been kind of going around my head while I was, doing my day-to-day work about new approaches to Earth observation modeling to do with embeddings, and I used that time to dive deeply onto those topics and um, really make very good use of that time, and ultimately that led me to Legend.
Yeah, and with Legend, from my understanding, also comes Clay, and speaking of foundation models, I believe that's how I actually came onto the idea or the topic of foundation models is through Clay Earth. Tell us about Clay Earth, its capabilities, and also tell us about some of the other foundation models that are around. I think I remember us speaking before about the likes of Terramind and Prithvi. But yeah, take the stage, please.
Mhm. To start with, what is a foundation model? And this applies to Earth observation, to language, to computer vision, to anything. But a foundation model is a large model that you pre-train on a lot of data without labels, usually without labels. Um, and it's the basis for then turning it into something that you use in a downstream task. And there's various different ways of doing that. The kind of foundation model we have in Earth observation right now, or the majority of them, they really designed to take that model that doesn't necessarily do much directly. That the task it's been trained to do is useful for like creating the foundation. It's not useful for a downstream task. But then the idea is you bring your labels, and a few technical details don't matter, but you basically use your labels to turn that model into something that does the downstream task. And then you slot that model in more or less to a roughly traditional way of doing things, taking your data, running the model, this kind of adapted foundation model, getting your answers. Um, so models like Clay and Prithvi, that's sort of how they were designed to work and how they were designed to be used. So Clay is a particular foundation model developed by the Clay Foundation. Two of the co-founders of Legend previously founded the Clay Foundation and developed the Clay model. But maybe one line on Clay. One of the key things about Clay is that it's designed to be adaptable to lots of different Earth observation data. It's some other models you have to use a very specific sensor or particular data product. Not so with Clay. With Clay, in theory, you could, or certainly been trained on a huge variety, and it's adaptable even to more types of data it's not seen before. Also, then worth saying about embeddings. So one thing you can do with these foundation models, instead of like doing the adaptation that I mentioned, is you can use them to generate an embedding. Now, an embedding is a compressed representation of the underlying data, so imagery in this case. And what's key is that it's easily searchable against. It's a bit like an index, and it has kind of semantic representation of that data. So it's not just saying like, what colors are in there. It's saying like what things are in there in a way that you should be able to take two very different expressions of a particular thing in the landscape in imagery, and that they should be kind of close in the embedding space. You can search and find both of those kinds of things very easily. That is the basis for having retrieval systems and search systems at scale. And you can do that with these existing foundation models, and that's the key. Even though they weren't really designed originally to do this.
It's probably the most comprehensive overview I think I've ever received on this area. So I thank you for that, and I'm sure there's plenty of people watching or listening who feel the exact same. Yeah, it's interesting, and I'm interested to see where and what lengths we go to with embeddings and foundation models. Whenever I hear or think about foundation models or embeddings, I do think of you and the work and the contributions you've made to this area. And I think as well, speaking before this recording, you have mentioned already some work, some projects or project that you've been putting together over the past 3 to 4 months, and that you've finally got to where you want to be. I'm not going to mention too much because I feel like that's for you to publish, when the time is right. But anyone listening, keep an eye out on Sam's work there on no doubt LinkedIn. Yeah, some exciting developments to come very very soon. Um, but to get to where you are today, it's not linear. It doesn't just go up in a straight line. I would imagine there are things that you have got wrong. And I'm keen to understand what's something you got completely wrong, not necessarily in year one, it could be any year for that matter. And how has that shaped how you do things today?
Mm-hmm. Um, yeah, I think the answer is thinking that maps are the product.
Right.
Sometimes they are, and many times they're not, I think. I love maps. I have a geology background. I've made geological maps. I love looking at all sorts of other kinds of maps and imagery itself. Love a good map, but um, very often the thing we actually want to get out of Earth observation data, the ultimate value in the end is not a map. It's something else. It's knowledge. It's maybe even something potentially as dull as a line in a spreadsheet, but a line in a spreadsheet which maybe tells you, this, is traceability or environmental sustainability of a product, and that has real meaning and societal value as well as economic value. And so we call this internally at Legend, we call it map brain, the instinct to reach for a map, like as this must be what we're trying to do right now, and that constantly fighting map brain. It's not about making maps, it's not about making pixels, it's about answering questions. And you can probably see how that relates to the broader message that I'm giving today.
So you've mentioned Legend there once again. Um, what's the real story behind how this company started?
Sure. So one clarification. So I'm not one of the founders of Legend,
Yep,
but yeah, Legend very closely fits with the journey I was already on. So I'm very pleased to be there. But
of course.
the thesis behind Legend is that these foundation models, as they exist, and as what we think they and future iterations can do, and also combining this like the generative component as well that I've mentioned. Um, all of this requires infrastructure. It's not just about having the models, especially on embeddings, to index the Earth. We need to create the embeddings at scale. We need to store them. We need to do retrieval over them. We need to build tooling on top. All of that is basically service stuff. And Legend exists as the entity to build that infrastructure, to build those those databases and those indexes of the Earth, and to provide them to users who want to use them for downstream tasks. So that's basically the thesis behind it's yeah, building the structure to make what I'm talking about the future of Earth observation possible.
I'm keen to understand as well, in regards to impact, with all of the work that you're doing at Legend, all of the work that you have done in your career so far, this revolution or this kind of innovation in generative AI or geo AI, embeddings, foundation models, all of this fantastic stuff. I'm keen to understand how you now define impact and if your view has changed since you started out in this particular area of work.
Sure. I think my first perspective on impact was when I was finishing up my undergrad in geology and was realizing that climate change was a big deal and something we needed to deal with, and something I therefore wanted to work on. And what I did was then I went and did a PhD, and my thesis on impact was very much about it's contributing to science, contributing to knowledge, and that is critically important. But later, after my PhD, I moved into industry. I moved into Earth observation, and there my understanding of impact and my thesis on impact, became much more boots on the ground, practical, like how solving real world problems. Um, in that context, there was a lot of like, measuring habitats for kind of biodiversity. There was, optimizing potato yields. There was a bit later, carbon sequestration, like, tons of carbon in the ground. These, pretty practical, um, measurable impacts. But as I mentioned, like my direction in the last year, and especially in the last few months at Legend, has been like moving more towards the kind of foundational technology. And I guess what impact for me now is as an enabler. I hope being able to develop the tools and the technologies and the products to enable a whole lot of other people to run with them and take them and yeah, do those kinds of things that I did in the past, but with hopefully far more impact than I could have alone. Everything I'm talking about, embeddings and generative modeling, like my perspective on the future of EO is basically these two pillars, like embeddings to find, generative to understand.
So forward guidance. I want to get your take on what this area is going to look like X years from now.
Sure. So my thesis that I've kind of been dancing around, but should probably stop and actually state, is that we have a lot of problems in Earth observation, find things at scale, understand them in depth, and that we have the tools to do that now. Models that can generate embeddings and foundation like frontier AI models for generative. So embeddings to find, generative to understand. That's my view of the two future big pillars of Earth observation, built on what we've done so far with foundation modeling, but taking it a lot further. And that's what Legend is building, more or less, the infrastructure and connections to make that a reality.
And do you believe that there are any, let's say, systems today, not just in the areas of foundation modeling or generative AI or embeddings, are there any systems today that you believe may not exist anymore? Something that may, become legacy? Because you mentioned earlier that 5 years ago, we were in a completely different state. I would imagine, 2025 it's a fitting year. What's going to happen in 2030, right? I'm keen to understand, if we was to have this conversation 5 years from now, what's not going to exist anymore? What do you think is going to happen?
Yeah. I think very few people are going to be training their own models, like task-specific models anymore from scratch. That almost certainly will completely go away. People will be using off-the-shelf foundation models, not like the ones we have today. Ones that much more like in language and computer vision that you can prompt to do the tasks you want to do. Maybe there's some fine-tuning happening. Maybe there's some like distillation to make smaller versions more efficient. But what we have now, a lot of people, building models from scratch, or even just like taking foundation models and fine-tuning them, I think a lot of that's going to go away. A lot more will be, there are models that have the capabilities already, and that it's more or less are going to be a lot of evaluating, figuring out if anything needs to be tweaked, and efficiency. And that there will be a big queryable Earth database that Legend is serving, and probably others too.
Love it. So lastly, bit more of a creative question, and you can talk about this however you wish, whether it's personally or you as a business over at Legend. If you had let's call it a moonshot budget with no strings attached, what do you think we need, and what do you think you would build tomorrow? Be creative, sandbox, come on, let's have it.
Yeah. Unfortunately, the Sam answer and the Legend answer are very closely aligned right now, so I can kind of sort of answer a little bit of both. First, or maybe Legend and Clay. First, build Clay version 2, and to me, Clay version 2 should be deliberately designed as an embedding generation model in the first place. Right. We know that there's a lot of things that, Clay version 1 works pretty well for embeddings, but there's a lot of things we know we can do better. And given our experience at Legend of actually like building the systems and retrieval stuff, we know exactly, I think, what Clay version 2 needs to be. So I would go make Clay version 2 a basis for number 2, which is I would use Clay version 2 to embed the entire Sentinel 1 and 2 archives and Landsat to make all of that queryable, and set up a system to do that for every image coming down from space. Basically make all of that searchable and discoverable. And if it's really moonshot, I'd probably start having conversations with commercial companies about how to do the same with their data too.
Well, look, thank you so much for joining us today. People need to watch this one. People need to listen to this one. If there's anyone who, knows about this stuff, in my opinion, it's yourself. I'll be sure to forward anyone your way if they do have any questions on, the reason as to why I say that is because there's a lot of people who also could be listening and watching now who come from, academics, who maybe are looking from the outside in, maybe looking to make a move into this particular space, who want to understand, where should they invest their time? Where should they train up? Where should they, enhance their knowledge? And, from a staffing perspective, the work that you guys are doing is exactly the type of skill that I think would be required to stand out in this particular field. So, I take my hat off to you. I take my hat off to the folks over at Legend and Clay there, and I think everyone would be behind me in saying best of luck to you all. We hope you continue to develop and innovate as you are. Some really, really exciting stuff to come.
Thank you so much. And if I may give a last thought in response to that, to re-echo it, embeddings to find, generative to understand. If you want to come into this space, learn about one or both of those, embeddings and generative as applied to Earth observation. They are the keys to the future.
Awesome.
Thank you, Sam.
Awesome. No problem at all. Well, look, thank you. It's been an absolute pleasure. Thank you so much for your time. And for anyone who has listened and watched to this point, I thank you once again and wish you all the best in your days until the next episode. Goodbye.
Thanks very much. Bye-bye.
Hello, and thank you for watching today's episode of Earth Observed, powered by brink AI. If you're interested in joining me for an episode of your own to discuss a topic of your choice, do get in contact with me. And of course, if you are looking to scale your team within geospatial, Earth data, or atmospheric AI, please do get in contact. I'd love to understand how I can support you. Until next time, have a great day.